Hello there. Chapter 11, Lesson 8, Part 2, or Day 2, because this is graphing and it's quite a bit different than what we were doing with solving the rational expression equations. So I split it into 2 days. So today I'm going to use a lot of different colors and highlighting if you want to pause and get any of that for your notes. So again, we are graphing. So we earlier in this chapter talked about direct variation and inverse variation. It says the inverse variation models you graphed in lesson 11.3 are a type of rational function. A rational function is a function where, okay, this is just function format that replaces the y, equals, and then you have a polynomial divided by a polynomial. So maybe a binomial divided by a binomial, or a trinomial divided by a binomial. But that is what is going to give you a rational function. In this lesson, you'll learn to graph rational functions whose numerators and denominators are first degree polynomials. So you're not going to see an x squared or an x to the third. Using long division, such a function can be written in the form, we're going to use this a lot. Okay, so y equals a over x minus h plus k. And each of these variables has a different job in this equation. Okay, so your x and your y will still be pairs of numbers together that make all of the points on the graph that you're creating, okay, like x comma y as a point. So we are going to end up making a table. The graph of the rational function, okay, looking like that, right? The graph that you create is called a hyperbola. It's a pretty cool graph, whose center is the point created from the number that is in this h position. Okay, so h is the x value of this particular center point, comma k will be the y value of that center point. Okay, so center, choosing a different color. Center, h, k, and this dot right here that I just highlighted in blue is that center point that I'm talking about, created from the there will be numbers there where the h and the k are. The vertical and horizontal lines that go through that center point are called asymptotes. Fun word, really cool. If we were in school, we'd be having fun with that word. Okay, asymptotes of the hyperbola. An asymptote is a line that the graph approaches. Okay, so the graphed lines that you are creating will be curved. They get super, super close to these asymptotes, but they will not touch them. While the distance between the graph and the line approaches 0, the asymptote is not part of the graph. Okay, so in blue, do you see these dashed lines? These are your asymptotes, right? They're invisible. Think of them like invisible walls. They're really not part of your graph. Your actual graph, when you plot the points, will be these 2 red lines. Curves, I shouldn't call them, maybe a line. Okay. Okay, so those 2 red curves are actually your graph. So that is your hyperbola. Okay, your hyperbola is created by those 2 curves. We're going to go ahead and do example 1. I'm going to give you a step process for this. My dog's having a fit and no one's here to help me, so you get to listen to the dog bark in the background. Okay, so step 1. Find that center point that we were talking about, HK. Okay, so if this is your equation, and here is your most general format of the same thing, that number 1, notice this is x minus. We have x minus. So the 1 is what your h would equal. A positive 1 because minus is the subtraction sign, part of this problem right here. So your H is going to be a 1, this 1. And your K is going to be this 3. There's a plus sign in the problem. There's a plus sign in the problem that we're working with. So our HK is going to be 1, 3. I have examples where the signs will be different, so I can explain that there. This is your center point. It helps you create the asymptotes. It is not part of your graph. Okay, so step 2, plot the center point on your graph. Okay, I'm going to do that, I guess, in red. Okay, so the point 1, 3, 1, 1, 2, 3 is right there. That's my center point. Step 3 is going to be draw the horizontal and vertical dashed lines through that point. Those are called your asymptotes. Okay, so if that's my point right there, horizontal, vertical, okay. You can pause, you can copy that if you need to. Back off from that a little bit there. Okay, step 4, you need to make a table and graph your actual hyperbola. Right now we only have like a setup going on. We don't have the graph of the actual hyperbola or the equation at all. So step 4, make a table and graph hyperbola. As for so many graphs that we've had in the past, to make your table, you are choosing x values, putting the x value into your problem. Okay, highlighting here. Here's my x value. Putting my x value into this problem, solving this math, and getting a y value back out. Okay, I'm going to rewrite. This is my math problem, right? So I'm taking 2 and I'm going to divide it by whatever I put in for x, subtract 1, get that answer, and then add 3 to get my y value. Okay, so I'm putting x right here. It's my suggestion that you try to use numbers that might maybe make your life a little easier. It's also my suggestion that if this is your center point and your x value for your center point is +1, you need to pick some x values on the left of that and some x values to the right of that to see where your curves for your hyperbola are going to end up. Okay, so I have some numbers that I'm going to put in here for you. We'll say -6, -4, -2, 0, 2, 4, and 6. Let's just do the same on both sides. All right, I'll talk through this one kind of slowly, but I am not going to literally put every single number in there in the yellow where I'm putting X. You can do that on side paper if you want. Maybe I will show you that part, I guess. You don't need to see the graph at this time. So if my x value is a -6, I'm going to go up to this problem here and put a -6 in for x. So y equals 2 over -6 minus 1, and then I'm going to add 3. 2 over -6 minus 1 is a -7, plus 3. In other words, this problem is like 3, take away 2/7 since this is negative. If I start with a whole number 3 and I take away 2/7, I should have 2 5/7 left. Okay, so I, again, in the beginning of the year, really stressed fractions, hoping some of you, that this comes easier for some of you now. So my y equals 2 5/7 if I do 3 minus 2/7. Okay, so I'm going to put that in my y in the table for when I plugged in -6. I got 2 5/7. All right, new problem. Y equals 2 over, I'm going to put in -4 where that x is. -4 minus 1 plus 3 becomes 2 over -5, or -2/5 plus 3. 3 minus 2/5, 2 3/5. Okay, go back here, 2 3/5. All right, another problem. Y equals 2 over, I'm putting a -2 in here, -2 minus 1. In other words, 3 minus 2/3. And I should get 2 1/3. I'll show you why I'm getting fractions and what this graph's going to look like. Put a 0 in. Y equals 2 over 0 minus 1. That's just a -1. So y equals 2 divided by a -1 is a -2. Oops. 3 minus 2 is 1. Put a 2. I'm not going to continue to show all my work. You can if you would like. Okay, so I'm going to put a 2 right here. 2 divided by 2 minus 1 is 1. Positive 1 this time. So 2 divided by 1 is 2. 2 plus 3 gives me 5. I'm going to put a 4 in here. I think I just want to keep showing my work. Okay, so y equals 2 divided by 4 minus 1 plus 3. Y equals 2 over 3 plus 3. Now I'm adding. So 2/3 plus 3, 3 2/3. And then put the 6 in. Well, 6 minus 1 is 5, so 2/5 plus 3, 3 2/5. All right, let's graph all of that. So -6, 2 5/7. Don't forget that this, the red, you might want to use a different color because the red are my asymptotes. They are not my x and y x-axis, y-axis. Okay, be careful. My center of my graph is still here. So -6, 1, 2. Can you see that? 1, 2, 3, 4, 5, -6, 2 5/7. 1, 2, 5/7. I don't know. It's just gonna be up there, right? -4, 2 3/5. 1, 2, 3, 4, 2, and just make it lower than the other one if you possibly can, but they're very close. -2, 2 1/3, 0, 1. Okay. Look at those points. I'll bring that in a little bit. If I were to put like a half in, I would get some numbers down in here. But this curve, remember, it approaches your asymptote, but it doesn't reach it. So your curve, sorry, this is so tiny, but your curve is going to look something like that. Now, you will know you're graphing something wrong or you're getting incorrect points if you don't have curves in opposite or diagonal locations. You cannot be getting any points over here. None. No points up here. Your points better lie up here, similar to this, but on the opposite side. So let's go to our table. The next point we have is 2, 5. So from 0, don't forget, don't go from your asymptote. 2, 1, 2, 5. 1, 2, 3, 4, 5. 4, 3 2/3. 1, 2, 3, 4, 1, 2, 3 2/3. And then 6 and 3 2/5. 1, 2, 3, 4, 5, 6. 1, 2, 3 2/5. And your curve should be looking something like that. All right, there you go. Put that up there so you can take a picture or pause, screenshot, pause it, whatever. So again, find that center point, the numbers where the H and the K would be, graph that center point or plot it on the graph, draw horizontal and vertical lines through that center point. They are not the red dashed lines, they should be dashed. They're not part of your graph. Just my blue curves are actually my hyperbola or my graph. All right, on to example 2. This is where we're going to talk a little bit about those sign changes. All right, so the original equation looks like this. Y equals A over, that's an A, X minus H plus K. So maybe think about how you could change this so you have a subtraction or addition sign in it, I guess. Y equals 2 over, how can you write X plus 1 but with subtraction signs? Wouldn't that look like X minus a negative 1? That's the same as adding. And then I need an addition sign here, so I could say plus negative 3, right? So that point, my center point, highlighter, where'd you go? Ran away on me. H, K, H, K. Step 1, find HK. It's going to be a negative 1, negative 3. Step 2, graph it. Negative 1, negative 3. Step 3, draw the, draw the lines, the dashed lines through it. Horizontal, vertical. All right. Let's see. Step 3, we had, oops, that's step 3. What was, sorry, step 2 was plot that point. Step 4, table and graph, right? Okay, so we have to go to the left and to the right of that center point, can put some of the same points in here. That's at a -1, isn't it? You can use the same ones if you want. I'm going to show you what some of these do. All right, so -6. We are going back. I still want my yellow highlighter. I think I found it. All right. So again, my x values, this -6 is going right here. All right, so I'm going to talk you through this a little bit. If I put a -6 right here, a -6 plus 1 is a -5, making this a -2/5. Subtract 3, or -3 minus 2/5 more would be a -3 2/5. Okay, all right. -4, it's going right here. -4 plus 1 is a -3. Makes this a -2/3. Take away 3, -3 2/3. -2 plus 1 is a -1. So 2 over -1 is a -2. -2 minus 3 is a -5. Putting 0 in for x. 0 plus 1 is 1. 2 divided by 1 is 2. 2 minus 3 is a -1. Put the number 2 in. 2 plus 1 is 3. Now this is a positive 2/3 minus 3, or you could think of it as a -3 plus 2/3. So you should get -2 1/3. Put a 4 in there. 4 plus 1 is 5. This is now 2/5. -3 plus 2/5. You are left with -2 3/5. If you put a 6 in there, you get 2/7. -3 plus 2/7 is -2 5/7. You're going to have some fun with those fractions. Take your time, write it out. Like, look at all this work I showed on that other one. Sometimes, I'm just saying, sometimes that it's faster to write all that out. I know you don't want to, but I'm telling you, it's faster. Okay, so I have my asymptotes and center point drawn. I am now plotting points to actually create my graph. So -6, -3 2/5. Remember not to go back. This is x, this is y. So -6, 3 2/5. 1, 2, 3, 4, 5, 6. -3 2/5. So 1, 2, 3 crosses the line, and 2/5 I'm going to say is there. -4. 1, 2, 3, 4. -3 2/3. 1, 2, 3 2/3. Is further down. It's not a good point where I put that, but that's okay. -2, -5, -2. It's hard to show you. 1, 2, 1, 2, 3, 4, 5. 0, -1. Well, I guess I could, well, let's just do 0, -1. So that means now that I switch sides, this curve or this side's done. I would like to see at least 3 points. So notice that I'm doing quite a few, but 3 points on each side would be great. I have a -2 1/3. So 2, -2 1/3. 4, 1, 2, 3, 4, -2 3/5, -2 and further down. 6, -2 5/7. 1, 2, 3, 4, 5, 6, -2, and we'll just really low. Okay, so again, approaching but not touching. Your table, you should know this about me now. So I'm going to be checking these numbers. I mean, graph them as close as you can. It's not easy to graph those, but when I look at this, this is your accuracy here. Okay, not that you can put them like in a totally wrong place on your graph, but you know what I'm talking about. Okay, now example 3. When your original equation is not in this format, y equals a over x minus h plus k. Do you see you don't have plus or minus anything here at the end? Then you need to use your long division skills from lesson 7. Which you guys rocked. I mean, really, that was probably the best lesson of this whole quarantine business. Okay, so I have to do 2x minus 1 on the inside divided by x minus 2. I'm going to remind you that you're really asking yourself just x times what makes 2x, and that's 2. And then you need to multiply like the distributive property. So this will be 2x. This will be negative 4. However, I am subtracting. So a negative 1 minus a negative 4 is like adding 4. So you get 3. Negative 1 plus 4 is 3. Kind of done here, right? So I'm going to go back up to the top and write plus, because that's a positive 3 over x minus 2. Now somebody will be like, Mrs. Stofflet, this doesn't look like this. Original format, right? Well, if you're adding two things, there's nothing to say that you can't flip them around. So I can write this as y equals, and just put this in the front, 3 over x minus 2 plus, and then put the 2 in the back. Okay. All right, now it is in that same format. I have even a subtraction sign there and a subtraction sign there, so my h is going to be this 2, and my k is going to be this 2. So my center point is 2, 2. Okay, so we had to do the long division. I did flip the order of these because adding is commutative. So I have my center point in my step process, 2, 2, graph it, asymptotes, not forgetting that this is your x-axis and your y-axis. Make a table and go about graphing. I'm going to make a vertical table because I like to. All right, so I don't know, use the same numbers if you want based on where we're at. Maybe another one. We'll see. Because I like to do math. Okay. You could use either. This is just a different formation of the same thing. So you could put your x values into either equation, but it's easier just to put it into one. Okay, so I'm going to rewrite it. Y equals 3 over x minus 2 plus 2. We're putting our x values from our table right there. So if I have a negative 6, putting it right here, negative 6 minus 2 makes that a negative 8. And you still have the 3 on the top. So this problem is like 2 minus 3/8. I should be left with 1 5/8. Put a -4 right there. So -4 minus 2 is a -6. 3 over -6 is like a -1/2. So 2 minus 1/2 is 1 1/2. If I put a -2 here, -2 minus 2 is a -4, making this whole fraction a -3/4, plus 2, or 2 minus 3/4, would be 1 1/4. If I put a 0 here, I get a -2. I now have a -3/2. -1 1/2 plus 2 leaves me with 1/2. Now, I put this 2 in here on purpose, but 2 minus 2 makes 0. Ding, 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 ding. That's like a, you can't do that. So if I put a 2 in there, we have to write that that is undefined. We are not graphing that. As a matter of fact, it lands on an asymptote. Got to be careful not to say that wrong. Okay, so we're going to write undefined because we got a 0 in a denominator. 4. Put a 4 in there. 4 minus 2 is 2. So now this is a positive 1 1/2. Plus 2, you get 3 1/2. 6. 6 minus 2 is 4. This is 3/4. Plus 2, 2 3/4. 8. 8 minus 2 is 6. 3/6 is a half. Plus 2, 2 1/2. Okay, go ahead and graph. -6, 1 5/8. 1, 2, 3, 4, 5, 6, and 1 5/8. -4, 1, 2, 3, 4, 1 1/2. That's easier to graph than some of these others. -2, 1 1/4, 0, 1/2. So only half of the way up. Again, 2, undefined, and we're already to this point. I guess I could have put a 1 in there. If I go back to the problem and I put a 1 here, I'd get a -3, right? Because 1 minus 2 is a -1. 3 divided by -1 is a -3. Plus 2 is a -1. So 1 -1. If you want to see a better picture, you know, you put more numbers in. That's what I do. Graph that. 4, 3 1/2. 1, 2, 3, 4. 1, 2, 3 1/2. 6, 2 3/4. 1, 2, 3, 4, 5, 6. 2 3/4. And then 8, 2 1/2. 1, 2, 3, 4, 5, 6, 7, 8. 2 1/2. You could have put in the number 3, because if you put 3 down here, 3 minus 2 is 1, 3 over 1 is 3, you'd get 5. 1, 2, 3, 4, 5. That's kind of a nicer point up there to have to make your curve. Okay. All right. I'm sorry I wasn't showing that to you the whole time, but you can take a picture of that if you'd like. And there you have it. I think I might have adjusted the assignment a little based on the calendar that was put out on Sunday or Monday morning. So check Google Classroom, use the Google Classroom problems to do. I actually haven't assigned very many. And yes, this is graphing, and some of you might not have graph paper. So you can go online, you could do free graph paper, you can screenshot graph paper, you can come up with ideas, or if you must draw the graph paper, you might just do that to annoy me, but you know, if you really wanted to, you could make graph paper using a ruler and make it exact and use some precision. But if you have to like sketch the graph paper, I might live. All right, so good luck and have fun with this.